Kho is an open source community engineer at Prefect. An open source workflow orchestration management system. He was a data scientist for 4 years, working in the energy and HR space. Outside of work, he is a contributor for Fungi, an abstract layer for Pandas, Spark, and Dask. He also helps organize Orlando machine learning data science meetups. Kevin, we're so happy to have you here, teaching us all about Prefect. I want to see how I can level up my skills. So we're gonna talk about orchestrating some pipelines and do a live workshop. A live workshop with Prefect is about to happen right now. And as always, we've got our trusted friend Ben from Galileo is joining us to field questions in the chat. Well, look at that, we're gonna be rocking. Let's keep it going, yeah. I just realized, you know what song that is? That's all the cool kids with their pumped up kicks. Better run, outrun my gun. Oh, the cool. I didn't realize that beforehand. What's up, everybody? That was my my attempt to welcome Kevin. Thank you for joining us, man. It's great to have you here, and I'm excited to let it go. We've got a lot to cover, so I'm going to kick it over to you. As usual, we've also got Ben here with us, who's going to be helping out and going through whatever you're going to present us with, Kevin, so that we make sure everyone is on the same page. Feel free to ask us questions in the chat right now. We are looking at that chat. We are monitoring it. And yeah, Kevin, man, welcome.
Thank you. And thank you for the song. Yeah, so should I just get started?
Yeah, please do.
Okay.
Unless you want me to sing more.
No, I'm fine with that, but I'll go ahead and get started. I have a Git repo that has the code for today. I sent it in the chat if anyone wants to follow along. We'll be doing more code stuff later. For now, I'll share my screen first and give a brief overview of Prefect, and then we'll dive into the code portion. So I'll share my screen. Does that look good to you? All good? Okay. So yeah, hey, hello everyone. Welcome to an intro to workflow orchestration with Prefect. And today we'll be using Prefect to orchestrate a machine learning pipeline and using other open source tools, Pandera, Tune, and Evidently.AI. So yeah, not me, although I also introduced with the song. I'm a open source community engineer at Prefect. My primary job is helping people, helping our users in our community adopt Prefect. So I mainly interact with them through Slack, get to see what issues they're running into, helping them write their data pipelines or their data workflows. So today, this agenda, what we're going to do is just talk about workflow orchestration in general. At the very least, you should be able to leave here knowing what workflow orchestration is if you're not familiar yet. And then we'll do a simple problem. And then we will try to scale out to Dask. But then if that takes a bit too much time getting the cluster and stuff, then we'll just go with the other open source tools that we're going to demo and making that pipeline. So with that, let's start with the workflow orchestration. Let's say you have a standard machine learning pipeline. You have a database, you're pulling data into some Parquet file, combining that with data from an API call, manipulating it in Pandas, training a machine learning model. And while you're training this machine learning model, you output some artifacts to some art registry like MLflow, and then maybe you deploy your model, right? And if you look at this, there's a lot of interdependent steps here. And the failure behavior of downstream event tasks is not really well defined, right? Like if an API call fails, what do we do about this transformation? And if this database intermittently goes down, what do we do about this pipeline? Do we just stop everything from running? Or do we just retry after 10 minutes and see if it succeeds? And then maybe after a certain number of retries, we decide to just call it quits and end our flow. Or maybe our model, like what if it doesn't converge? What if you have a model that's taking too long to run? Should you have a timeout on it, right? So these are, there's a lot of ways this specific pipeline can fail. And it becomes even more the number of possibilities increases exponentially as you get more interconnected with your data pipeline. So in the top half here, we have a simple BI pipeline combining a couple of Parquet files into Pandas, pushing it to a database. Maybe we have a dashboard that sits on top and looks at this database. And then we have a machine learning pipeline as well. Maybe it uses some connected data, some data that's shared between the BI pipeline and this machine learning pipeline. And then we do this transformation, and this is the pipeline we had earlier. And if you look at this, there's just so many ways that this can fail. And as you know, machine learning practitioners, part of our job is handling for that failure. So a lot of times, hey, if the API fails, maybe I'll just do a time.sleep, do a retry. If this model is not converging, or if it fails because of some bad data that went in, maybe we just send the reports and a notification somewhere. Maybe we have to code a timeout. If this data comes in malformed, what kind of checks do we need to do in order to figure out what to do with this data? Like, do we still run everything? And malform can be like, what if the data comes in, but it's not the values that we expect, right? If the values are acceptable, they won't throw errors, but maybe they will have downstream consequences, right? So in that case, what we need to do is we need to have certain checks to make sure that the values are reasonable. So in general, everything that I described, like this engineering against failure and having code paths explicitly there to handle failure events, this is what we collectively call as negative engineering. So you can do these try except yourself, but you can do these like timeouts yourself, but what you're going to find is that the more that you code to handle these failure events, we actually spend more time on negative engineering than compared to positive engineering, which is what you set out to begin with. You wanted to put a machine learning model into production. You wanted to solve a business use case. That's positive engineering. That's what you were explicitly, hired to do. But now what happens is, in order to maintain these pipelines, you have to end up spending more time on negative engineering. And the reason Prefect is both the company and the open source project. And the reason Prefect was founded was to eliminate negative engineering, right? Often you hear that like that modeling portion, that's just 10% of the data science job. If we think that 90% of engineering time spent is on negative engineering, then if we can just reduce this to 80% or 70%, we can double or triple developer productivity, right? So with that, I'll introduce Prefect. As a company, our mission is to eliminate negative engineering. We are an open source workflow orchestration tool. Right now, we have these are pretty recent numbers. 8,000 plus GitHub stars, close to 14,000 Slack members. And I personally am responsible for the Slack community. Even if you're not looking to use Prefect tomorrow, we encourage that you just join the Slack community because there's a lot of interesting discussions. We have a very active and very skilled community for sure that there's certainly a lot to learn from. I learned a lot just maintaining the community as well. So we are a Python-based workflow orchestration tool designed for the modern data stack. And when we say designed for the modern data stack, we integrate, very well into that PyData ecosystem. We have a native Dask integration that we can use to scale out your workflows, run them in parallel or distributedly. And Prefect today is in a transition between what we know as Prefect 1.0, which is the current product out there, and 2.0, which is currently in technical preview, but will be off technical preview in maybe a month's time or a month and a half's time. And it will officially go into its beta. So if you need a production use case, like if you want to use Prefect for production use case today, then you would go for Prefect 1. But today I'm gonna present Prefect 2.0, and they're very different, non-compatible. But Prefect 2.0 gives a lot more out of the box for free for an average user. I mean, Prefect 1 does as well. You can sign up for Prefect Cloud today, no credit card needed. You get 20,000 free task runs. You can just use it, no problem. But Prefect 2.0, as we'll see later, is more lightweight. You can use it out of the box. There's a lot of cool functionality that comes with it, right? So with that, the current state of Prefect, there's this thing called Prefect Core, that's 1.0, and there's Prefect Orion, which is now 2.0, and we're gonna present 2.0 today. So in general, the reasoning behind coming up with Orion and making these breaking changes and moving to a 2.0 was because workflow orchestration used to be synonymous with the concept of a DAG, right? The directed acyclic graph, where you make your the graph of the steps in your pipeline, and this graph would be traversed during execution, and then depending on upstream states, you kind of determine what to do downstream, right? And we felt that the DAG was very constraining for a lot of our users, and a lot of our users had to make really hacky workarounds to work around this DAG. And Prefect 2.0 brings the workflow orchestration experience more Python and makes it more Pythonic, removes this DAG constraint so that now you can have really dynamic workflows. You can add tasks in the middle. You can have first-class subflows, for example, where like if I want to retry a specific section of my DAG, I can easily do that. Before, what happens is like if you have task A, B, and C, and A succeeds and B succeeds and C isn't quite what you want, you can't go back and retry A. But now with Orion, you can do stuff like that. So it's way more dynamic. And so we'll just do a quick problem first, just to get a feel for Prefect. And then after Prefect, I'll go over the other orchestration. The other open source projects we'll be covering today. So for our Prefect problem, what we want to do is we want to track Dogecoin prices, and we want to get an alert when there's a dip. We're really concerned with steep drops where it's like, oh, it drops 10%, and then like we want to get an alert so that we can go look at it and go purchase some, right? So I'm gonna show the code in my editor instead, and we'll walk over it together. So I'll make it bigger. Okay, so this first line, I'm just setting a Slack webhook explicitly so that you can we can get a Slack message, the alert, just so we can see it. But normally you just configure this on your own ahead of time, and then we are just some standard imports. This is all just native Python without Prefect first, and then we'll show how we're going to migrate this workflow to Prefect. So first we have this format URL. We are just hitting the CoinDesk API, and then we are just getting a start time and end time. The start time will be 10 minutes before now, and the end time will be like the current datetime.now. And then we construct our URL by doing our URL plus the coin. So if this is Doge, then this will be Doge, and then plus the params. So now we have this format URL. We're gonna call it inside here, inside our get data function. So we do a request.get on this formatted URL. Doge goes in here, so we get Dogecoin data, and then we get the JSON of that and pull out this field. And what this does is it gives us 10-minute prices. It gives us minute level prices for the last 10 minutes. And then we have a data frame now. This is a Pandas data frame that we created, and it's gonna go in here to this detect dip function. This is just a very naive implementation, but what we're gonna do is we're gonna get the top of that interval, the bottom price of that interval, and then we do some calculation like what percent of the top is this bottom of the peak is this bottom value, and then now we can just do some like 100 minus that and kind of get some percentage. So if this represents a dip, not exactly, but it pretty much is analogous to a dip, and we can say, hey, if this dip is above this threshold of 10%, we return true, and otherwise we return false. And the last part is we're going to send a Slack message. So if you use any workflow orchestration tool, you're going to get a task library. And this in Prefect 1 simply just looks like this. And you just do your message. But again, we're in the process of porting over our Prefect 1.0 code to Prefect 2.0. And along with that, the task definition has changed. So our task library will need some adjustments, but maybe in the next month or so, we're going to start to see our tasks in Prefect 2.0 already. So for now, because I don't have the task library for 2.0, I'll just code it myself, use that environment variable I talked about, and then send a message. And now I can call these all of these tasks that I defined above. I can easily call them in a function that takes in the coin and the threshold, and I can get the data for it, detect if there's a dip. If there is a dip, I'm gonna send a Slack message, and this will work, right? This code will work. I'll try to run it, and now I'll try to run it, and maybe we can see. I should get a Slack alert because I set this threshold to 0. So because this is 0, whatever change will fire a Slack alert, and I should be able to get it. So I'm gonna do python doge.py. Okay. I will make sure that I have the right Slack webhook URL, and then if not, I will just not work with Slack. This was working a while ago. I'm sorry. Let me just check real quick that I have the right webhook URL, and if not, we'll just move on. And now is a good time for any questions as well, if there are any.
Yeah, feel free to drop any questions in the chat. I know that Slack was down yesterday for a couple of hours.
That's a good point. That's a good point. You know, my job is managing the Slack community. So yeah, it was a pretty uneventful morning because there was nothing to respond to.
Yeah,
I'll say I got a lot of work done yesterday when Slack was down.
Oh really? We'll try this again, and if it doesn't work, I'm just gonna print for now. Okay, it's not working. So what we'll do is we'll just print this, and we'll say this has a dip right now. I'll also just check. I tested this before, and I know this key is correct. So I'm just gonna copy it over and try one last time. And if it fails, we're fine. Oh, that's because I changed the print. Send to Slack. Okay. Something changed in the last hour with my webhook, so it's not working. So we're just gonna print this for now. Okay, so now we can see that Doge has a dip, and this is gonna work. And assuming my Slack task actually works, right? What I can do now is this: I have this function, and I can spin up a box in AWS, EC2 or something like that, and I can just put an infinite loop to put this in production. And maybe I can do like an import time and time.sleep. And I say, run this for 5 minutes, run this every 5 minutes and check if there's a dip. And if this notification did work, then I get a notification every 5 minutes, right? So now this will work fine until it doesn't, right? Because the moment this API fails, this API call, like APIs fail intermittently, you can have I guess this this is bad that this Slack webhook is not working, but stuff like that does happen. And then once it does happen, like let's say this were Slack was out, right? So let's say this is an intermittent thing that will fail. It would interrupt my program because it raises a client exception. Or in over here in the request, it would fail because it raises a it requests an API error, right? And because of that, what happens is this gets interrupted and I have to go back in and I have to restart it. Also, it's very hard. Like what happens if I wanted to change from Dogecoin to Bitcoin or something? I would probably have to interrupt this, make a new one, put some input and then rerun. Oh, sorry, I got a Slack notification. No, different Slack notification. Never mind. I thought it finally came through. We'll go back. So now I would have to do this, but then I'd have to change this to Bitcoin. Now what happens if I wanted to monitor multiple coins instead? Maybe I do something like this, right? But the point is that if this were a production, even as a hobbyist, we can do better, right? If this were a production use case, there's many ways this can fail and interrupt this program, right? And it doesn't take a lot of code to bring this to proper workflow orchestration, as we'll see. So the next thing I'll do is I'll show you what this looks like when we bring it to Prefect, right? And what we're gonna do is from Prefect, we just import, you can ignore this line for now, we just import task and flow. And for the things we want Prefect to track, more like functions, we call them as tasks. So here I'm gonna say, wrap this as a task because this is the API call. So this is a point where it can really fail. And now I can say, we want max retries to be 3, and we want to retry every 10 seconds. So now if the API call fails, it's going to automatically retry and then proceed downstream, right? The second, and then for flow is more analogous to like a collection of tasks. So more like your main function or your Python script. And these are the semantics for workflow orchestration in Prefect. So the second thing is this task now. This task and then the second thing is I'm going to put a task on detect dip. So now we're going to get the output of this task and pass it to this next task later in the flow. And then the sending a Slack message will also be a task. But these don't need retries as much as this API call because this is a point where it can really fail. And then we had a function here that where we put all the functions together. This is more like a main function. And now what I'm going to do is I'm going to call this as a flow. And you can ignore this task runner for now. I'm going to comment it out. So we can, we're going to call this, we're going to put a flow decorator on top of this. The name will be check dip. And this is a bit different from what we had. I'm gonna tab some stuff out. So let's say we had coin equals Doge. Now this is pretty much the same as what we had earlier. And you'll see that there's barely any change, right? I'll copy this section and I'll put it side by side with our flow. And what you can look at the stuff that changed. So these are the same. This is the same. This changed a bit, and I'll explain why that did. And then if Slack was working, this would be equivalent. So the only thing that we had to change was this if dip.wait.result is equal to true, right? And I'll talk about that more a bit. But now that we have this as our flow, we can also just run this check dip, and we'll see what the output is. Stack might fail again. Yeah, so I'll just change this to a print again. But notice, so now we get these logs. So Prefect is tracking the state. You'll see some stuff like this. Hey, finish in state completed, finish in state completed. So now we were able to run this flow, right? And it actually succeeded. We were able to prototype it. So there's a couple of things to notice here. Number one is that we can pass the data natively, right? So this returns a data frame, and this data frame goes into this detect dip. And if you look at other workflow orchestration tools, a lot of them will require some kind of intermediate persistence in data, so that you persist it in the upstream tasks, and then you load it in the downstream. And now we're just able to run it like normal Python. The second thing is that there is the DAG is created for you very Pythonically. There's no like set upstream, set downstream, stuff like that, because this is this task and this an instance of this task, and this task eventually gets passed here. Prefect will know that this get data is an upstream task to the detected. And the last thing I wanted to call out is this .wait.result, right? So in Prefect 1, everything inside the flow block had to be a task, right? And that's what I said, like everything has to be like this kind of pre-registered ahead of time, and it had to conform to the DAG requirement. And if it deviated just a slight bit from the DAG requirement, Prefect would conk out and say, oh, I don't like, hey, you deviated away, like you can't do that, it'll throw some error. And that's true for other workflow orchestration frameworks as well, right? Because the DAG is a pre-registration, a build time, a compile time thing, and your runtime has to match that DAG. So now, if this were Prefect 1, what this would look like was like this, with case dip true, do some other task. And this case was a task that we made to mimic the behavior of the Python if. But now that we don't have this DAG requirement and we can just submit tasks on the fly during execution, what we're going to see is that we can just use the native Python if, right? And in order to, these are futures of the task. So now we just have to materialize that future. This becomes a regular Python object now, and then we can do some other tasks. This would have been the send to Slack task, right? So now you can have this wait for this future to resolve, and then you would submit this task, right? And then the other thing to show about Prefect 2.0 is I noticed I ran this. Under the hood, what's happening is that there's actually a SQLite database that backs Prefect 2.0 locally, Orion. So I can do Prefect Orion start to bring up the UI. This starts up the service, and I can follow this link and I'll open it. And you'll see that we have the runs. This check dip is the one we just did. And if I go to my flow runs, you'll see this hilarious skunk. This name will match the name that I had here. So Prefect generated a flow run for me. So Festive Mosquito failed. That was the Slack task that failed. Hilarious skunk is the one that succeeded. So now you can see that this mosquito is the one that failed. I can go in here. I can see, hey, why did this run fail? Oh, it failed because of that Slack task, right? That didn't fire. And then I have the logs. The second one succeeded, this hilarious skunk. And then we can see the task that succeeded. This radar, maybe it'll be more entertaining to do it here, right? We can go here and we can, as data goes through your system, your flow, you're going to see these lines connect to represent the passing of data. And then the deeper it goes, the more co-eccentric circles you're gonna have, and then because this Slack task failed, we did not we got this red indicator saying that it failed, right? The reason that this Slack task is on the same circle as this is because we had to materialize the Python tip object. So this broke the lineage, and then we submitted another task after breaking that lineage. But if you stuck to that DAG and to that paradigm of having everything as tasks inside your flow object, then you would just see a straight dependency all the way through, right? So the interesting thing here is that for Prefect 2.0, we already have this API that's running, even though the service is not running, there is this API that's tracking state of your runs. And even though this is all running locally, I'm not connected anywhere. All you have to do is pip install Orion, Prefect 2.0, and it comes with the UI, it comes with the API, it comes with the interface that we use to define our flow, and that all comes together. So it's a very lightweight thing. You can now host your own orchestrator with just a simple pip install. You just do Prefect Orion start, and this now starts that service that spins up the UI for you. But even without this this service started, you can already submit flows and run flows, right? And I'll just check really quickly if there are any questions.
I actually have.
Yeah.
While we're waiting for that for the channel for anybody else, I have a quick question about this flow paradigm because you brought up a change that I thought is really cool, and it's something that Prefect 1 already was doing better than other workflows, but it's even more native here. Is this intrinsic data passing from task to task? What if that data frame isn't like a Pandas data frame, but what if it's some other data frame that's maybe memory mapped, or maybe it's a distributed data frame like a Spark data frame? Can you still pass it from task to task, or how does it work when it's not like an in-memory object?
Yeah. I can tell you for Prefect 1, you can. What you do instead is you would have the syntax would be with worker client, and this is for Dask specifically, and then you would move the guys in there so that you have a client, and then you're submitting the task to that. So now what's gonna happen if you have this? You can pass the client, or and then this would run with this client inside your task. You can use that client to submit for Dask. I think for Prefect 2.0, this paradigm isn't explicitly worked out yet, but we already have a Dask executive. So there's also a discussion there in the relationship of Prefect and Dask, but we have a Dask executor and Ray executor. So if I wanted to run this, what I could do, and I'll just demo this real quick. Before I get back to this thought, I'm gonna uncomment this Dask task runner, and I can use the Dask task runner here. And instead of one coin, I'm gonna track multiple coins. So I'm gonna add Bitcoin here to the mix, and I'm gonna add Ethereum. And now I can say for coin in coins, and this is again native Python onto this list. I can run this as is. And then now what this does is that for Doge, it's gonna go through this. For Bitcoin, it's gonna go through this. For Ethereum, it's gonna go through it as well, right? Oh, sorry, I want to run the flow. And then we'll see this Dask. We're getting the errors because of the Dask multiprocessing trying to spin up. Send to Slack is breaking, but what we're gonna do is we're gonna spin up the Orion server again, and then we can look at this failed flow, and this one should contain multiple coins, right? So if we look at the graph here, we have we're gonna see 3 get data calls. That's for the Bitcoin, Ethereum, and Doge, right? So the question here is that, so now I have a Dask task runner, and I can just submit stuff to the Dask task runner. So here we have Prefect calling Dask. The thing, sorry, we're using Prefect as the interface to Dask, right? But then the scenario that you're describing is hey, we have a big data frame, and how do we actually just use the Dask interface without Prefect doing the submission for us? And that's when you would use something explicitly like the client here, right? Or you can actually submit your, like, imagine you, right? This flow code doesn't really block you from having native Python code. So imagine you can even just you can spin up your own cluster here. Like, for example, you can do like Fargate cluster, right? And you spin it up here, and then you do client and then you pass the cluster. I think it's like client and then cluster like this. And then now you have this client and you can interact like this thing you can pass to downstream tasks. So I think for the answer to your question is, even if you have for Spark, it's a bit trickier because normally the paradigm with Spark is not this like, hey, there's a client and I'm submitting things. So for Dask, for Ray, this is the paradigm and it's a lot easier. For Spark, it tends to be like Spark submit or that kind of thing. So in that kind of case, it's just like you can pass a Spark data frame around. The only thing you need to keep track of is like Prefect. We don't have this yet in 2.0, but in 1.0, like Prefect will persist intermediate copies of that data frame if you're passing it from task to task. And what the reason for this is that, hey, let's say you have a flow with task A, B, C, and then A succeeds, B succeeds, and C fails. Persisting those intermediate copies lets you restart this flow from the point of C, right? And then you load it from B, and you don't need to rerun those previous steps. So when you work with big data frames, you just have to be wary about this persistence and turn it off explicitly so that you can you're not like persisting this data frame so many times.
Makes sense.
So, oh yeah, if there are any other questions, feel free to interrupt me. Okay, so if there are none, what we're gonna do is we're gonna go over, in our agenda, we have other open source tools that we're gonna go through. I'm gonna go through three of them. So unrelated to Prefect, but definitely can be used well with Prefect. So number one, I'm gonna talk about Pandera. Pandera is an open source data validation tool primarily for Pandas data frames. They have since extended different backends, so now they support like stuff like Modin, Koalas, Ray, stuff like that. But it's still mainly the Pandas interface, right? So what we're gonna do is we're gonna create this baseline and this new data. I have this setup function in this utils.py here. You don't need to really know what's in it. I wrote out the data specification that this generates. So we're not going to use all these features, but we're just going to go through them. Oh, I need to make this bigger. So we have a category. This is A or B. And then feature one will be uniform from 0 to 1. Feature two will be from 3 to 4. Feature three has to be in between feature one and feature two. So feature three is our first like, hey, this actually has to look at other columns. Feature four has to be normal, mean 0, standard deviation 1. And I think feature 7 is the important one. So we'll see that later. And then the rest, I think I drop it later anyway. So we're gonna plot features 1 to 3. You're gonna see feature 3 is in between 1 and 2. 2 is between feature 2 is between 3 and 4. Feature 1, the blue, is between 0 and 1. And then what we're gonna do is I have the baseline and the new data. So the new data is corrupted in some way so that we can trigger validation errors. So if we plot the errors for the new data, we're gonna find that, hey, there are some instances where feature 3 is way above feature 1, feature 2. You're gonna see sometimes feature 2 also dips below the range, feature 1 dips below the range. This is the feature 4. We're gonna see that the baseline data has mean 0, but obviously the new data kind of drifted a bit. I don't think we'll see this in Pandera. I didn't explicitly code for it, but in Pandera, you can use some hypothesis testing as your validation rules. And then feature, okay, I guess feature 7 we'll go through later. Or maybe I'm not gonna cover it because of lack of time, but we'll just start with the general Pandera feature set. So Pandera, the design philosophy was outlined by the author of Pandas in the Pandera in the GitHub issue, right? And he said that the three things are: number one, minimize the proliferation of classes in the public-facing API. So you shouldn't have to learn a lot of things in order to use it. Number two, and I think this is the more important one, the schema definition interface should be isomorphic to the data structure being validated. So if you're doing like a Pandas series, then you should be able to use a validator that's column-based. If you're doing a Pandas data frame, you should be able to do a data frame check, right? And then number three, just flexibility, expressiveness. So we're gonna import Pandera as PA, and then we have a check on feature one, just a column check. So just this single column, it has to be between greater than 0, less than 1. And this is just to give you a clue of the standard validators that come with Pandera. And then obviously there's an in range 3 to 4. And then that's feature 2. So now you can call feature 1 check.validate. This checks this column. Same thing. Number 2, you check. And then if you call validate, it just returns the data frame as is. So it's kind of like a read-only operation. And then I'm going to do it on the new data, and you're going to see that we're going to get a trace back. Obviously, the same validation won't work because we corrupted the data. And when you use a data validation framework, it gives you all of these like failure cases and the appropriate indexes for them. So that's the purpose of using such a framework. And then we have this. And then we have this data. So if we show the column level, but if you want the data frame schema level, the data frame level, you have to use this data frame schema. And this data frame schema takes in a couple of column objects, right? We said feature 3 was between multiple columns. We'll discuss that later. So in general, you would make this schema, data frame schema, and then you can call it on your data set. Notice that you can do stuff like, hey, required equals false. You don't even need feature 10. You can do stuff like coercing. I'm coercing this column, feature 5, to be a string, especially when Pandas reads in CSVs. Sometimes the types are messed up, so you can use Pandera to coerce those types for you. And then we can have our column object similar to earlier. And then you're nullable. Can this be null or not? Now, for the feature 3, which has to be greater than feature 1 and less than feature 2, we have this checks. So earlier was column-based, now we have checks. And checks takes in the data frame level. So now we can define a data frame level check, and then we can do our validate call. But then the immediate issue is that, hey, we have this check on feature 3. We know it's going to fail on the new data because the new data is corrupted. But the problem is you get, if you look at all the failure cases, you only get failure cases from from the first check, right? From this feature 1 check. And the reason is that, hey, it's going to run through the checks. It sees that check. Oh, it's going to error out. So the answer there is you have to use this lazy equals true for lazy validation. And now it will run through all of them before actually giving you an error, right? Throwing all the results back out. And I think that's pretty much it for Pandera. The last thing I'll show is that, hey, and this is straight up from their documentation. If you were to actually use this in production, maybe you could use these decorators. So you can pass this data frame schema with this check input, and now this data frame will be checked to see if it fulfills those rules. And then you can do the same on check output and check this check IO should be a decorator, right? So that's it with Pandera. The next tool I'm going to cover is Tune. And Tune is an open source library for hyperparameter tuning. Again, I'm involved with the Fugue project. Tune is a subset of the Fugue project. This one, Tune is specifically for hyperparameter tuning. And there's a PyData talk linked here as well. So the thing with Tune is, if you want, it provides a grammar to express your search space for hyperparameter tuning. So the first thing we're going to do is we're going to import these space classes: space, grid, randint, and choice. And it's pretty intuitive. So space is the search space that you can look at, right? So we do space, and then we list, and we get this. Now, if you do grid, here we say B is a grid of 2 to 3, and C is a grid of A and B. Now you can do list space, and because we have these two grids, we get 2 times 2, the combinations of those. So we have 2A, 2B, 3A, and 3B, right? So we can mix and match. The second, and then we have this, so after grid, we have random. So sometimes you want a random search. Here we define a space and we say, hey, there's a random number between 0 and 1, and then a choice between A and B. And then once you define this space, you can sample with a seed. So you say, hey, I have this space. I want to sample from this space 3 times, and now we have 3 random combinations. So there are hyperparameter tuning frameworks that let you create a random value during runtime, but now we push that all back up during build time, and it's a lot easier to access. And you can keep track of it on a higher level also. And then you actually don't even need to sample. You can actually leave this, like this rand or this choice, you can leave it straight up as without sampling. And the reason for this is because especially this library will just know that, hey, there's no sample here, predefined sample. So what I'm gonna do is I'm gonna use Bayesian optimization to get a random value and then converge to the best value, right? So now you can even do stuff like combining this random expression with grid. So here we have grid 1 to 2. So B has 1 and 2. And then this is the Bayesian optimization. So hey, we have this this deterministic value for B, and then Bayesian optimization will optimize this. Or you can sample also and just distribute. So here, the last thing is you can also combine spaces together with this syntax. So we have 3 spaces here, and now we can add the search space together, right? You can also use the sum syntax to add these spaces together. And this just provides a very easy way to set your search space. And then you can also do a cross product. So you multiply like all combinations of this search space combined with all combinations of this search space, right? And then Tune has this has some helper, like you don't have to use the helper methods. I think the space is already very expressive, but you can also bring the training to Tune where you can say, hey, suggest an sklearn model for me using a search space. So here I just have logistic regression, and then it will, you pass your train test, and now it will create a model that fits that. So same thing if you have like a Bayesian optimization, it will also use like hyper OPT or Optuna to find the best combination for that under the hood. So here we use the sum expression to combine 2 search spaces now, and then we can get we can suggest an sklearn model. Here the random forest classifier was better. And then there's 2 more things. One is that you can partition. So this is the Titanic data set, and now you can say partition by the gender. So it's gonna run this search space over male and then over female, and then produce the best models for those. And then the last thing, of course, is that in order to distribute this, you want to say, hey, run all of these combinations on Dask and run them or on Spark, and it makes all these jobs for you and submits them. So it's kind of in line with Prefect. There's some overlap there, but we're just going to use the space of Tune and then bring it to Prefect. And the last thing that I'm going to show is Evidently.AI, which is for detecting data drift. I hope I can just run this straight up and we can see the output. So again, I'm making my baseline, my new data. We know that this new data is corrupted. So what's going to happen is I'm going to see a drift between this old data and new data. So these are just the imports. In general, with Evidently.AI, what you're concerned with is making a report. So you choose the report you want first, and they have like 6 different kinds on their documentation. And then once you're concerned with making a report, you kind of just fill in your data and then it generates that report for you. So here is an example of a report. Here I'm looking at the drift of my target variable. I have a category in my dummy data, that's A or B. So now I can see, what's the percentage of A and B for each of the data set. Here, there's not really any drift, but what we should see a drift in is by feature, we should see like feature 4, we know the normal distribution changed. So there is a bit of like drift that you'll see when you compare. And then over here in what I know there will be a stronger drift in is if I actually look at the data drift without the target. So now I'm going to use the data drift, and here you can see, Evidently.AI detected a drift in feature 7 and detected a drift in feature 4 and detected a drift in feature 6. So 3 out of 6 had drift here. But of course, if you actually have a pipeline that you're running, it's not practical to have these dashboards. They're expensive. I mean, they can take a while to generate as well because you're fitting some distributions. So what you're gonna do is you're gonna, or it's more practical for you to calculate the JSON first. And this JSON is basically what powers this anyway. And then when you have the JSON, you can filter out the exact measurement you need. Like for me, for this specifically, I'm interested in data drift. And it's kind of hard to see, but you should see something like metrics. And then in metrics, you should see how many drifted features there were. So there were 3, and half of my features drifted. And that we're gonna bring this to Prefect. I know we're a bit out of time. Is it okay if I go like 10 over the hour?
I think that's fine. I can stay here.
Yeah.
Okay. Thank you. So what we're gonna do is we're gonna again use Prefect, but Prefect is an orchestration tool, so you need to use it. It orchestrates like other stuff, right? So what we're gonna do is we're gonna have a machine learning pipeline, a model training pipeline specifically, that will use Pandera to validate our data, use Tune for the hyperparameter tuning portion, and then use Evidently.AI on the inference side. So on the training side, I'm gonna load my data. This is just the dummy data that I showed earlier with Pandera. I'm not gonna use all the features. That's not important. You just need to know I have some features. There is some drift that we'll see later. But then what I can do is I can use those numeric columns to make a machine learning model to predict the categorical. And then I am going to predict. I'm going to use Pandera over here, where I make my data frame schema, and then I validate the data. And then we know this will work because this is on the baseline data. And then the next thing is I use Tune, and I define my search base using Tune. So now I have search base 1 and search base 2. And then I can, depending on my config that comes in, I can say, hey, just use the linear regression space, just use the random forest space, or use all the spaces. And then I can use this method to pull in like the actual configuration as a list. And then for each of those configurations, I'm getting the model type and passing the quarks into it. And then I return an instantiated model. So it's going to be like a random forest classifier with max sample 0.8 with max depth 3. That's what this will output, a list of those kinds of things. And then training a model should not be anything surprising. I think we just do a simple train. We take in a data frame, we do our train test split, we fit predict, calculate accuracy, and append that to this dictionary. So this dictionary contains the trained model, the class name, the parameters that created that model, and then the accuracy. And now once I have all of these outputs, I can pass them to this get best model. I just get the maximum accuracy and give myself the model object, return the model object. And I save the model object using joblib. I dump this into a pickle, and then I wrap everything in a flow. And for this specific use case, I'm going to use a Dask task runner because I can be training multiple jobs. And now I can train them in parallel. Even on local, I can use all 4 cores of my machine. This is a local executor, although you can bring it to Kubernetes easily as well. And then these are just my task calls. So I load the data, validate with Pandera, get my models, and then here I'm making a list of model outputs. This is a Python list, and I'm gonna append the trained model for each of those. So for each for each model, this model will be a list of models, but then I'm gonna make this a Python object by waiting on that feature. So now I have a native Python list of models, and I'm gonna loop through that list of models, train a model on a data frame, append it to an output. And then I can get the best output using this get best model function, and then I'll save it, right? And this should work. I'm gonna do the ML training. And because we're a bit pressed for time, I won't look at the dashboard yet. We'll look at it later, I guess. I'll go over the inference pipeline first. So this is all the models that it trained. We did our, hyperparameter tuning. You can record them somewhere if you want. I just didn't put that in code. And then we have our model inference. And I think the Slack webhook will fail, but the idea here is that we can use Evidently, and if there's a drift in model detection, I can easily get a Slack notification, hey, we're not running your pipeline because there was a model drift, right? So we load our data. This is the check drift. And again, this is just like the profile that I showed earlier in the notebook, where we calculate a profile of drift detection. And then we can just return that profile and work through it later to get the metrics that we need in order to determine what action to take. And then we load, this is just loading the model, nothing special. Sending to Slack, this is failing, but ideally it should have worked. And now we can run our flow. Notice I don't need the Dask task runner here because we're just doing one process anyway, so there's no need to parallelize it. So I'm not going to attach the Dask task runner and just use the normal task runner. So here I'm going to load in the data, pass them over to this check drift, and then I'm going to materialize this check drift result so that I can actually get that JSON that I'm interested in. And then now that this is a JSON object, I can use the if statement to pull the specific and drifted features. I can compare it to the threshold drift that I'm like, it's 2 features, too much is 3 features, so it's a parameter here. And I can compare it against that. And if it's too high, then I'll send a Slack alert. Or else I'll just load the model, make predictions, and output the results. So if I, the first thing I want to highlight here is that notice this integer. So by defining this type annotation, Prefect will coerce the parameter that comes in and see if it can be coerced to that type. So for example, I'm going to say test here. This will fail, and you're going to see the error, ML inference. Invalid parameters and marked as failed. That's because this could not be coerced as this, right? As this type, this integer. So Prefect does that type checking validation for you. And then now I'm not gonna pass in anything. We're gonna use the default value of 2. I have 3 drifting features. So this should just go to the else and make that prediction for me and save it as a parquet. Maybe if I delete this preds.parquet, you'll see that it's created. So now I can run the inference portion. And you should see that it's, oh, sorry, this sent to Slack. It still went here. I think my, there are too many. So I need to make my threshold higher to make that parquet. So now you see the Preds Parquet was generated, and then if we use the default, you'll see that we hit this guy instead, right? So now the last thing I'll do is I'll go to my Orion dashboard, and I'll show you what that looked like. Again, it's going to be these runs are actually being persisted under the hood, and we'll see them when we navigate to the UI. By the way, what's nice about this is that this is a interactive dashboard, and you can play with the filters also. And you can make your own filters. So you can configure the dashboard exactly how you want. And then just to show you, this is the inference flow that succeeded. It made a parquet. It's just, we loaded the data, checked for drift, and then looked for the best model. And then the other tasks are not there, precisely because I had the freedom to work with it. Like this is not a task, and this is not a task. And that's why they don't appear on the UI. So now I'm just calling native Python because just to show that I can, if ever it makes sense to. This is also native Python, right? So those don't appear in the UI. And with that, I'll end my presentation. I do have some announcements, and then I'll really end my presentation. So announcements to make. Number one, we do have resources. Again, I demoed Prefect 2.0 here. We do have a production ready Prefect 1 if you want to use that. You can check the Orion docs here. Feel free to join our Slack community, prefect.io/Slack. I'll answer your messages, like any questions you have. And we are hiring a lot of positions. We have 16 positions open, I think, on our careers page. So we are definitely hiring. And if ever you're interested, do feel free to reach out as well. And with that, thank you. I'll open the floor for questions.
Dude, that was awesome. Thanks so much. I will wait just a sec because I think it is streaming through and people might have some questions. So I just want to let everyone know, thanks for joining us. As always, we're doing these once every other week. So if you want to come to the MLOps community, we have this happening. I imagine a lot of you are coming from Slack already, but if you're not, come join us. We've got cool merch, which you can see. I've got some bad things happen to good data merchandise that we've got on our webpage. And also, right now, we're going to be doing something pretty interesting, which is networking. So we're going to try and do something new. If you go to the left tab on the platform that you're on and it says match, you click on that and then you should see something that says get started. And so we're going to have a little networking event where you can just randomly match with people in the community and hopefully talk about what you saw on here or talk about anything else when it comes to orchestrating pipelines, how you've done it, what have been some difficulties, what has been cool. Feel free to jump in there, meet up with someone, get to know someone new, make a new connection, all of that. For now, we're going to let you all do that. And yeah, this has been awesome. I really appreciate everybody coming and doing it. And we will see you at the next one. Take care,
Thanks,
everybody. Jump into the match.
Thank you.
Thank you, Kevin. This was awesome.
Thanks, Kevin.